All right, number 7 is super important. And it's actually, yeah, it's very similar to number 2 with one additional step. So you're given this graph. You're given acceleration. Oh, this is actually really cool because this dovetails perfectly from what I was just talking about. Dovetails, is that a thing people say?
No. It's a woodworking skill.
And I can woodwork like a beast, so it was appropriate that I just said that. Okay, so here's our graph. You're told that this top acceleration up here is 20 meters per second squared, right?
Yes.
All right, and so the question wants to know what's the net work. So, net work is equal to net force times distance if your force is constant. Is my force here constant? No, my acceleration's not constant, right? So my net work is the integral of net force with respect to x, yes?
Yep.
Okay, but my graph doesn't have net force on it, it's got acceleration. So this is the integral of mass times acceleration with respect to x, yes? Follow?
Yep.
So that mass times, because mass is fixed, right?
Yep.
Okay? Now, in simple words, maybe pictorially, I don't know if that's a word, but what does this represent? Area under the curve, right? So I'm trying to find the work performed between x equals 0 and x equals 8. So all I'm going to do is I'm going to find the area under the curve, which to me looks like it's 1/2 base times height, so 4 times 20. So this area is 80 meters squared per second squared, right? So that's the red part, and then multiply by your mass. And you're told the mass is 10 kilograms. So just multiply and you get 800 kilogram meters squared per second squared. That's joules. Does that make sense, you guys?
Yes.
So if you're a little sketchy on that, here's another way that you could do it and get to the same result. And I'll be honest with you, I think the first time I solved this on my own, here's how I did it. I thought to myself, I'm trying to find work, and I know that work is area under the curve. But the area under what curve?
Force.
The force position curve, right? Well, I'm given an acceleration position curve. What do I have to do to acceleration to get force? Multiply by mass. So basically what you can do is you can make a new graph with the same position, 0, 2, 4, 6, 8. And if I multiply any given acceleration by my mass, that'll give me the net force, won't it?
Yep.
And my mass is 10. So take all of these accelerations and multiply them by 10. That tells us at the top my net force is 200. And so here's my net force graph. And then find the area under that. And it gives you 800, right? Because half of base times height. And that's a little bit less calculus-y, right? So